We're talking about the cumulative distribution function. We like to name it capital F of x, and we've been talking about it at very particular points. Now let's talk about it as a full function. Let's talk about it for a dice roll. Let's start by plotting a few points. F of 0 is the probability that I roll my dice and the number that comes up is less than or equal to 0. Well, standard dice don't have any number like that, so this probability is 0. F of 1 is the probability that I roll my dice and it comes up less than or equal to 1. So that's the same in this scenario as saying what's the probability that I roll a 1. Rolling a 1 is the only way that this happens, and that happens 1/6 of the time. So f of 1 is a sixth. Now let's think about f of 2. This is the probability that I roll my dice and the number that comes up is less than or equal to 2. So that's the probability of rolling a 1 or a 2. And we saw that in a previous video. This is 2/6 or 1/3. There's two ways that I can be less than or equal to 2. Let's do f of 3. This is the probability that I roll a number and I get something less than or equal to 3. So that's the probability of rolling a 1 or a 2 or a 3, and that's half of all total numbers. So this is 1/2. F of 3 is 1/2. Now something to remember, it's easy to forget, this is not the probability that I get a 3. It's more than that. It's the probability I get a 3 or anything less than 3. The probability of getting a 3 is a sixth. So on these 7 numbers, it's not too hard to define, but I can define it on other numbers as well. Why don't you, on your own, evaluate these numbers? What I want you to do now is think about these 3 numbers, f of a half, f of -1, and f of 7. Pause the video, figure out what they are, and then come back. F of 1/2 is the probability that I roll my dice and I get something less than or equal to 1/2. That never happens. The smallest number I can get is 1. So this is 0. So what I don't have is a straight line pointing up. F of -1, that's the probability that I roll my dice and the thing I get is less than or equal to -1. That never happens. So that's 0. And in fact, from here, I can say, well, the probability of getting any negative number is 0. The probability of getting anything less than or equal to a negative number is 0. Now let's think about f of 7. This is the probability that I roll my dice and the thing that comes up is less than or equal to 7. That always happens. It's never equal to 7, but that's okay. It's always less than or equal to 7. So if x is greater than or equal to 6, then the probability that I roll my dice and I get something less than or equal to x is 1. The probability of being less than 7 is 1, the probability of being less than 8 is 1, the probability of being less than 9 is 1, and so on. So we have this flat line over here. Similarly, if x is less than 1, then the probability that I get something less than that is 0. The probability of being less than 1/4 is 0, the probability of it being less than half is 0, the probability of being less than 3/4 is 0, and so on. And this doesn't change until I get to 1. So I have this jump discontinuity. What I want you to do now is fill in the rest of the gaps. So between 1 and 2, what is this function? Between 2 and 3, what is this function? Between 3 and 4, what is this function? And so on. What we get for the rest of this function is more flat lines. Say I want to know f of 2.1. That's the probability that I roll my dice and it's less than or equal to 2.1. So because we only have these discrete values, this is the probability that I roll a 1 or a 2, which is a third. And that's the same as f of 2. So I get flat lines like this, and so on. This is the cumulative distribution function for rolling a standard 6-sided dice.